Okay, so we already talked about the process for solving equations. You already wrote this down. Okay, but we really only saw examples that were linear. We did see a couple quadratic examples, but that was like this number 15 from your homework, where you can solve it like a linear equation and then square root both sides. Okay, well, what happens if you can't just do that? Okay, what are we going to do in the situations where we have nonlinear equations? Okay, so our first example for today is this one. What is the issue with this problem? There's sine and cosine. Okay? We could always look for a GCF, but we don't even have the same two functions meshed together. Okay, so this is a problem. In order to be able to solve this equation, we are going to need to have the same two functions. That's not always the case, but since we don't have a greatest common factor to pull out, we're stuck. If only there was a way to change one of these to look more like the other. Oh, man. Okay, I'll hand these out in a little bit, okay, people? Okay. Which one do you think would be the easiest to change to look like the other?
The sine. The sine squared.
Okay, we have sine squared right here, which we know is a part of the Pythagorean identity involving cosine squared. So what we can do is we can change sine squared to be 1 minus cosine squared. Okay. Now we have an equation that involves all cosines. Okay. So we have 2 minus 2 cosine squared x plus 3 cosine x equals 0. Okay? What kind of an equation are we dealing with at this point?
You good?
Quadratic. And is this typically the order we see quadratic equations? No. We like them to be in a particular order, and I really like the leading coefficient to be positive. So what I'm going to do is I'm going to reorder this and multiply everything by a -1, both sides. Are we allowed to multiply both sides by -1?
Yes.
We are. So I'm going to do that and rewrite this as 2 cosine squared minus 3 cosine minus 2 equals 0. What? Saw you had a question. Equals -0. Yes. Okay. So now we have a trinomial. I promised you our factoring was going to be important. Here's where it becomes important. Okay. So you practiced some factoring way back last week. If you need to off to the side write it like this and figure out what the factoring is without the cosine, that is fine. We know 2c times c is 2c squared, right? And the only way to make this 2 over here is 2 times 1, but it's negative. Where does the 1 go? With the 2c, it's the only way it can go. And then since this is negative, this guy has to be negative, that guy has to be positive, right? Because we would get 1c minus 4c, okay? So if that's how we get this factored, then this would factor to 2 cosine x plus 1 and cosine x minus 2. Okay, so just like we would over here, we need to set each of these factors equal to 0. So we have 2 cosine of x plus 1 equals 0, and cosine of x minus 2 equals 0. Okay, let's start with the one on the left, because some of you, the wheels are already turning, right? If we solve this, we have the cosine of x equals negative 1/2. And that's a nice unit circle value, isn't it? Where is the cosine equal to negative 1/2? 4 pi over 3. And 2 pi over 3. I think we need a unit circle quiz. Is that a, I agree?
Oh, yeah.
Okay. I'll look into that. Okay, so those are those two. I wrote plus 2 pi in because the period of cosine is 2 pi. How about over here? The cosine of x equals 2. What's the range of cosine of x? What's the range of cosine of x? What's the range of cosine of x? Negative 1 to 1.
So that's not possible.
It is not possible. The cosine of x cannot equal 2, ever. Unit circle or not a possibility. Both cosine of x and sine of x have a range of negative 1 to 1. And so if we have something outside of that range, it doesn't work. Algebraically, it works, but we don't have an angle to satisfy that. So show me that you thought about it, but it doesn't work. And then these would be your only two answers. Is that okay with everyone? Okay. Very important example right here. Write it down. What is really tempting about this problem?
Get rid of the
What? Well, you mumbled, so I'm not.
No,
sure
yeah,
what
I
you
just
said.
thought about it. I can't do that.
What can't you do?
Subtract because it's multiplied by that. That's why I'm saying I can't.
Well, you can. Your first step is to subtract 2 cotangent of x to the other side.
Yeah.
But you can't squish them together. Okay? How many of you are tempted to divide by cotangent of x? Okay, you weren't. Okay. Some of us weren't. We cannot divide by a function that could be 0. Are we allowed to divide by 0? Okay. Could the cotangent of x equal 0? It could, which means we cannot divide by it. We cannot divide by a function. So, you were right. We need to subtract 2 cotangent of x to the other side. Now we can't combine these two because this guy's multiplied to cosine squared. However, what could we do? Yeah, since we have two terms that have something in common, it's called a greatest common factor, we can factor out our cotangent of x. Look for that greatest common factor, especially when you have a mix of like more than one trig function. See if there's a GCF before you start using identities. Okay? So here we have the cotangent of x equals 0 and the cosine squared of x minus 2 equals 0. Okay, well, where is the cotangent equal to x? Where's the cotangent of x equal to 0?
Pi over
2.
5 over 2, anywhere else?
2, 3 pi over 2.
Okay, if we're thinking about the unit circle alone, pi over 2 and 3 pi over 2. The period of cotangent would be pi. Now, how far apart are pi over 2 and 3 pi over 2? They're pi apart. So if you put just this one answer, it is sufficient. This is technically redundant, but I will let you be redundant if you want to write both of them. Back of the book is only going to have this guy right here. Okay? Over here, we have that the cosine squared of x equals 2, which means if we square root both sides, the cosine of x would equal plus or minus radical 2. Max, what would radical 2 approximate to be?
You mean like cosine?
No, just radical 2, the number.
Um.
No? Oh, man, I was trying to. Radical 2, if I put that in your calculator, what would you get? Is radical 2 bigger than 1? Is negative radical 2 less than negative 1? And what did we just talk about? That's not okay for sine and cosine. So we don't have any answers here. That's not a possibility. All right, 2 more examples together as a class. All right, what are your thoughts? Subtracting the 1 is a good start. Okay, we have a quadratic going on, so setting it equal to 0 is good. But there is a problem because we have secant squared and tangent. We can change secant squared to tangent squared plus 1. And now everything has the same trig function. What else is nice? The ones cancel out. So we don't even have to worry about a trinomial, do we? Okay. don't use an identity unless it's really going to help you, okay? Don't get too identity happy. Really, the Pythagorean identities are going to be the ones that you're going to see, that you're going to need in these types of problems, okay? All right, now we have two terms, both involving.
Tangent X.
Okay, and what did I say if there was something in common? Factor it out. We are listening today. And when we factor, we need to set each factor equal to 0. Where's the tangent equal to 0 at? Two pi, 0, pi. So I'm going to write 0 plus pi n. If you write pi plus pi n, means the same thing. Okay. And this was kind of a struggle on our test. Where's the tangent of x equal to 1? Okay. If you want to be redundant, you can also talk to me about 5 pi over 4 plus pi n, but you wouldn't need to write it. You could get away with writing just these two answers. Okay. All right. One more example, and then I'm going to give you a job. Okay? What is different about this example? The t has a coefficient. X, t, theta, y, b, a. Doesn't matter. Thank you. But this is different because inside our angle has a coefficient. Typically we just have a variable for our angle. Now we have a coefficient with that variable inside of our angle. Okay? That changes how we find our answer, but not the algebra to get there. Okay? We are still going to add 1 and then divide by 2. Algebraically, there is nothing else we can do after this step. That 3 is inside of our function. We can't take it out. Okay? It is attached to that t. So instead, let's think about the angles in which cosine is 1/2. Where does that happen at? Pi over 3?
Yes.
And 5 pi over 3. So what we can do is we can write 3t, our angle needs to be pi over 3 plus 2 pi n, and 3t, our angle, needs to be 5 pi over 3 plus 2 pi n. Okay, so the angle is 3t. Typically we get to just write x and be done. But our angle has a coefficient, so I keep the coefficient with the angle, and now we can solve for t. Now we can write t is pi over 9 plus 2 pi n over 3. And t is 5 pi over 9 plus 2 pi n over 3. And those would be your answers. You don't worry about that coefficient until you've identified the angles, and then you can divide it. Oh, there they are right there. Oh, I lost my activity. Okay, let me just